You read the title or saw the thumbnail, we're talking about how your cell phone works. This video, by the way, is part of a series on how your phone works. I recommend you watch all previous videos to fully understand this one. But before I get into anything, I gotta give credit where credit is due. Thanks, Reddit user Brick Tamlin, for the suggestion, and I hope this helps. And for this video, we're gonna start with Wi-Fi and how it works. Wi-Fi is where all those ones and zeros from last week's video can come from. How does Wi-Fi work in the first place? Well, Wi-Fi is a wave, meaning it has ups and downs at very specific intervals. If it went one up, one down, or cycle every single second, you would have 1 hertz. If it went one up, one down, one up, one down, or 2 cycles every single second, it would be 2 hertz. Wi-Fi runs with a very specific 2.4 and 5 GHz. But whoa, hey, what's this G thing in front of the hertz? Well, that stands for giga, which means billion. So Wi-Fi is either 2.4 or 5 billion hertz, or ups and downs per second. That's fast. Wi-Fi is 2 distinct hertz because then we only have 2 specific waves to look for. It's basically so you can have less interference. Okay, but how does this wave become ones and zeros? There is a cool box in your house that sends and receives data from the internet. This box basically gives the data from the internet a route to take, and it's actually called a router. So anyways, you request to go to a page, and your router accesses the huge World Wide Web by basically trying to pass your request through many servers and computers until it reaches the site, which then sends you the information you requested back to you through many servers and computers until it reaches you. But all this sending and talking is done in Wi-Fi, and also some wires along the way. So the real question is, how can you send information through Wi-Fi? To code Wi-Fi, you have to change the actual wave itself. So to make a 1 in Wi-Fi, you might make it like this. That is known as changing the amplitude. Basically, just making it taller or shorter. Tall waves could be 1s, short waves could be 0s. You could also do this. That is moving the wave a little forward, or changing the phase, which can be measured. More forward waves could be 1s, more backward could be 0s. Then you can do this. That is changing the hertz. A higher hertz could be a 1, and a lower hertz could be a 0. And after all of this, you can still combine these changes to represent more data. A slightly higher hertz and a slightly higher amplitude might be a 1-1, and a slightly lower hertz, but still that same high amplitude, could be a 0-1. So now that we have all these 1s and 0s, does Wi-Fi just code for each individual pixel on the screen? When a web page sends you its data, it splits it into chunks. And these chunks are sent across the internet, each looking for the fastest individual pathway to reach your phone. Then your phone gets the chunks and orders them back up according to the instructions, or headers, that were put on the chunks when they were split up in the first place. And to make sure you get the correct chunk, at the end of the chunks there is an error checking device, which, as the name would suggest, checks for errors and also corruptions inside of the chunk. But what happens if the chunk doesn't make it to you? When you get the chunk, you send a confirmation message back to the website. If the website gets the message, then it will just send the next chunk. If not, it will resend the first chunk because the website doesn't actually know whether or not you got the chunk. This can mean you actually did get the chunk, but when you send your confirmation message, it got lost somehow. In other words, you have a chunk, you send the confirmation message back, but it never reaches the website, so it sends the same chunk, and now you have duplicate chunks. What are you gonna do? Well, you can just discard one. It doesn't really matter as long as you end up with 1 chunk eventually. But to make things faster, the website might send a lot of chunks at the same time, and then resend the ones that just didn't get confirmed, instead of a back and forth conversation. But wait, there's also another system for apps and video games that use the internet. For apps and video games that use the internet, instead of sending a chunk, receiving a chunk, sending a message confirming you got the chunk, and all of that, the chunk is sent to your phone. then that chunk is sent to the right program on your phone. Basically, after your phone gets the chunk, instead of giving any app that chunk, it goes to the app you're using. So for instance, if you're using Skype, the chunk you want goes to Skype instead of Clash of Clans, since you're using Skype and not Clash of Clans. Okay, but why have two different systems for the internet and for apps and video games that use the internet? The reason internet video games and apps don't use many steps is because they need to be fast. And so you might not get all the chunks, but this is fine. I mean, if a chunk didn't make it to you, then most games can just make up for it. They might glitch or skip a little bit, and this is fine as the next frame will update. And there might be a small glitch in this frame, but another frame will load, and that's just how games and apps work. Plus, even if it did glitch a little bit, you normally don't care and it doesn't affect the actual gameplay that much. In the previous internet example, if a chunk doesn't make it to you, then part of the web page may be missing, and web pages don't have another frame to load, which is why the internet makes sure you get all the info, while games and apps don't care as much, since they can just make up for it, like I said. So that's basically it for Wi-Fi. The next video will be about many of the parts inside your phone. So tune in next time. Well, life is an experiment, and you are the scientist. Thanks for watching. Bye. Wi-Fi runs at a specific 2.4 far. So to make a 1 in Wi-Fi, you might take. At the end of it, there is a special device that makes shirts. It makes shirts. So don't use as many steps, is because they need to be fast. Oh, come on. Apps work. In other words, it doesn't matter if a chunk doesn't make it to you because it's the bar.